All right, so let's go right to the one that I said was a little bit new. So it's number 10 on the quiz. There's only one problem, like it, and we're going to do a problem today that's very, very close to the thing that's on the quiz, all right? But I'm going to review just a little bit first. So let me grab this graph. This can be helpful. You don't have to graph, don't worry about it, and I'm not putting any graphs on the quiz. Okay, all I'm doing today is just showing you why what I'm going to talk about is true. All right? Let's just push this over a little bit. Actually, yeah, we'll keep it right there. All right. What I'm going to do is I'm going to put a couple points on this graph. I don't know, let's put one right here. Let's make that look a little bit more like a circle. There we go. And I don't know, let's put one right here. There's just two random places, okay, on this graph. And what I'm going to do is I'm going to make a line that goes through those 2 points. And what do you think I'm going to find right now? I'm going to find the slope. That's right, okay? So I want to find the slope of that line. Now here's the 2 points that I gave you. It's this point right here. So let's find that point on the graph. Where is that point located? Well, we start here and we go to the left. 1, 2, 3, 4, 5, and then 1, 2, 3. So what is it? -5, -3. Again, I am not going to give you a graph on the quiz. Everybody hear me? Okay, I'm just going to give you the two ordered pairs. But I'm doing this graph for a reason, okay, for a particular reason. All right, what about this one? What's the slope of that one? 1, 2, 3, 4, 5, and what? 1, 2. So that's +5, +2. Everybody with me? All right. So now what we're going to do, all right, is we are going to find the what? What do you think? Find the slope. Now, if you had a graph, you could just do what? You could just count on the graph, couldn't you? Let's just do that for fun, all right, just to see what it is. And let's see if our math actually comes out to the way it should be. So let's go from one point to the other and rise and run. So how far would I have to go? I'd have to go to here, wouldn't I? Everybody see that? I'm going to go up to that height right there, and then I'm going to go over to that point. So let's count. 1, 2, 3, 4, what? 5. All right, so up 5. And then to the right, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what's the slope of that line right there? Reduce it 1/2. Okay? Let's just put the numbers in and see if it actually comes out to that. All right, it's always kind of nice for them to come out to the same thing. So how do we find the slope? Do you remember? Make a little fraction. And what do we put on top? The y's. Subtract the y's from each other. Yeah. You can go y2 minus y1, or if you wanted to, you could go y1 minus y2. It doesn't make any difference. We taught going y2 minus y1, so let's do it on this one. So it's going to be what? 2 minus... Is it? What's the other y? Right, the other y is -3. See, that's the second one, that's the second one, so it's going to be 2 minus -3. All right, what's the bottom going to be? Subtract the x's in the same order. It's going to be 5 minus what? -5. 5 minus -5. Let's see what we get. Minus a minus is plus. 2 plus 3 is 5. Right here, minus a minus is plus. 5 plus 5 is 10. Check it out. Does that look familiar? Yep, reduces to 1/2. So the slope is 1/2. Everybody got that? Yeah. All right. What I'm going to do now is I'm going to draw another line, but I'm going to draw another line with the same exact slope. All right? I could start anywhere. I don't care where I start. You can start right here. Let's just start right here. We got that point already on there. What do we say the slope is? 1/2, correct? So 1 over what? 2. So I rise 1. Do you see that? I rise 1, I run 2. Let's do it a couple more times just to spread out our points a little bit. Okay? So let's do that. Let's rise 2. Or I'm sorry, rise 1. Rise 1 and run 2. Yeah? Everybody got that? Rise 1, run 2. Now it's pretty easy, isn't it? Now I've stretched my points out a little bit because I just like to know that my line's going to, whoops, that's not a good spot. That's right there. Now check this out. Both lines had the same exact slope, didn't they? What were the slopes for both of these lines? 1 over what? 1 over 2, 1/2, right? So if they both have the same exact slope, what does it look like is true about those two lines? They don't have midpoints at all because they're lines. They keep on going forever. Just look at it. Look, use these markers. See these two? Right, they look like this. What does that mean? They're what? They're parallel to each other. Doesn't it look like it? Yeah, it doesn't look like they'll ever touch each other. Agreed? It's just going to keep going that way, and they'll never ever meet. All right? So it looks like those lines are parallel. What was true about both slopes? We'll call this line 1. Okay? What is the m? Why did I put m? Because that's what? The slope. Okay, so this is what? The slope of line 1. Everybody see that? And what was the slope of line 1? 1/2. 1 over 2. What is the slope of line 2? It's also 1/2. So when the slopes are equal to each other, all right, I'm going to put this. When slope 1 equals slope 2, what's true about the two lines? They're parallel to each other, exactly right. And that's what we're getting at today. All right, that's the kind of new stuff. It's not really new as far as the slope because we already knew how to do the slope. Okay, but just understanding that if you have two lines that have the same slope, then the lines are what? Parallel to each other. Everybody with me? Not everybody. Got a couple with their heads down, and you're losing out. Yeah, you're not listening if you're not looking. All right, that's my motto. It's not my life motto, but it's true. If you're not listening, if you're not looking, you're not listening. All right, so here we go. Let's do another one. So this is important right here. If the lines are, or if the slopes are parallel to, let me try this one more time. If the slopes are what? Equal to each other, then the lines are parallel. There you go. Finally got it. All right. Now watch what I'm going to do. I'm going to take, you're probably going to say, why are you doing this? Well, I'm doing this because it works. Okay. The slope of the red line was 1/2. Agreed? I'm going to put an arrow. This does not mean they're equal to each other, okay? It just, there's a relationship here. What I'm going to do is I'm going to do two things. I'm going to mess around with this 1 over 2. I'm going to flip the fraction. So if I flip the fraction, what would I get? If I flip the top and bottom, 2 over 1. And if I change the sign, so the sign of this was what? Positive. If I change the sign, what will the sign of this be? Negative. Okay, now why in the world would I do that? Well, I'm glad you asked. Because what I'm going to do is I could take either one of these lines. Let's take this second line right here. And let's start at any point. You can start at any point. Let's just start at that point right there. Okay? So let's take the slope of this one. Now, how did I get this one? What did I do? I flipped it, right? And I changed the sign of it. Okay? So negative 2 over 1. So let's take a point on this line right here. And let's do the slope of negative 2 over 1. And let's see what happens. So what would I do? Negative 2, rise, which means I go what? I go down 2, and I run how many? 1. So let's put a point right there. Let's do it a few times. Down 2, over 1. Let's do this one. Let's go up 2 and to the left 1. That's still negative 2, isn't it? Do you see that? Now, and let's do it one more time. Up 2 over 1. It actually hits right there. I want you to look at the two lines now. The yellow one and the red one. Look at those two lines. Does the yellow one look parallel to that red one? It's not parallel to it. What does it look like? Look, this would be parallel right here. See these markers up here? That would be parallel. What is this? Transparent? Is that what you're saying? What word are you saying? It's not con anything. They're not congruent to each other. Okay, they intersect each other. It is true, but They intersect each other here. They intersect each other here. But look, they specifically intersect each other. How? What do they form? Come on, we've talked about this before. What are these two lines? Starts with a P. No? I think we've done this before. What kind of angle is formed here? Look at the angle. We've talked about that for sure. A 90-degree angle. Okay, if two lines form a 90-degree angle, then those two lines are considered to be what? Not parallel. Any lines are straight. Not parallel, but what? Have we not talked about this? Perpendicular. Have you heard that word before? You guys are scaring me. So look, what does it look like? What kind of angle does it just look like to you that's formed here? It's a right angle. And it is. It's absolutely a right angle. Okay? So this yellow one must be what? What's the word? Perpendicular. Let's write it down. It's a very popular word in geometry. We're going to use it a lot more in the future. Okay? It's perpendicular. Everybody see it? So the red one and the yellow one are perpendicular to each other. Everybody see that? What makes it perpendicular? The slopes. What was the slope of the red line? Tell you what, let's do this. The slope of the red line right there. What was the slope of the red line? It was 1/2. What was the slope of the yellow line? -2/1, right? What did we do to the red line to make it into the yellow one? What did we do? We did two things. Not just switch it. I never said switch it. What do we do? What's that? Come on, I said it like 5 times. We flipped it, right? We flipped the fraction, and then we did what? We did one other thing. We did 2 things. Change the sign. Very good. Okay, we changed the sign. Everybody hear that? So, let me ask you this. Let's, I'm going to give you a couple words that are really important. But before we do that, let's just do a couple little test slopes here. What if I had the slope 2/3? What if I had -2/3? That's right. How would I get the slope of a line that's perpendicular to this one? I flip it, right? And then I change the sign. So it's positive. Everybody see that? Okay. So that's pretty easy, isn't it? Just flip the fraction. What's that word called when I flip a fraction like that? It's a fancy math word. Starts with an R. No. Just hang on. Come on. Just hang on to what I'm trying to do here. Nobody? Reciprocal. Thank you. Reciprocal. Is it because it's Monday? Is that what it is? All right. These are words that you've already learned before. Okay. Maybe we didn't talk about reciprocal in this class, but in other years, I know you talked about reciprocal. Now, watch what we did here. We took the opposite sign, didn't we? You could just say opposite, but I say negative reciprocal. Because what's the negative of -2/3? It's what? It's positive, isn't it? Everybody see that? All right. So it's the negative of a negative is positive. So when I say negative reciprocal, I'll put it in quotes. That's a phrase I'm going to use quite a bit. If the slopes are negative reciprocals of each other, what's true about those two lines? They must be what? Yes, I'm hand delivering this to you. Look, it's right above it. If the slopes of two lines are negative reciprocals of each other, what's true about those two lines? They are what? Perpendicular. That's right. So, what's true about the slopes? What's true about the two lines that have these as slopes? What's true about, they're perpendicular. Exactly right. Okay? You with me? What's true about those two lines? They are perpendicular. Agreed. Okay? What if the slopes are exactly the same? They're parallel to each other. Very good. Just like we did at the beginning. Okay? So, if the lines right here, do you see this? If the slopes of the lines are equal to each other, then the two lines are parallel. If the slopes of the lines are negative reciprocals of each other, then the lines are perpendicular. All right? Those are the two things that I want you to learn today. We just didn't have enough time on Friday or whenever the last time we taught this to do that, okay? So let's do a couple examples. What if I said the slope was -5/7 of one line, right? So one line has that slope and another line has this slope. What's true about those two lines? What do I know? What do they have in common? What is it? They're parallel to each other. How do I know that they're parallel to each other? It's not because they're both negative. It's because they're both exactly the same. That's right. Okay, they're both exactly the same. They don't have to be negative. All right, they could be both positive. For instance, what if I said this? What if I said the slope of line 1 was +4/3, and then the slope of line 2 was also +4/3? What's true about those two lines? They're parallel to each other. Why? Because the slopes are equal. They're exactly the same. We getting this? Okay. Let's switch gears a little bit. You know where I'm going with this next one, correct? What do you think I'm going with this? That's right. So let's do, what if I give you the slope of, I don't know, just make up a slope. -7/11. Let's go crazy. All right. So what if you had a slope like this? What would the slope be of a perpendicular line? It'd be +11/7. You got it. So what's true about these two lines? They are what? Perpendicular. Good. Now we're catching on here. Okay? Everybody see that? So all you got to do is look at the slopes. If the slopes are negative reciprocals of each other, then the lines are perpendicular. If the slopes are equal to each other, then the lines are parallel to each other. What about this? What if the slope of one line was 5/3 and the slope of another line was -5/3? Now you got to think. Are they parallel to each other? Why not? One's negative, one's positive. Means they're not exactly the same. Are they perpendicular to each other? Well, one's positive, one's negative, but you didn't flip the other one, right? Okay? So what you would say on this one is you would say neither. Okay? They're neither parallel nor perpendicular. Everybody got that? All right. Here's an easy one. What if you had a slope of 2/3 and you had another slope of -5/2? What's true? They're neither, right? They're not even close, right? Well, one's positive, one's negative. They've got a chance of being perpendicular. But look, 2/3, 5/2, not even close, right? All right, so that would be neither as well. They're both in green. All the greens are neither. All right, now, with all that said, let's do a problem that's very, very similar to the one on the quiz. Okay? You ready? So, we're only going to do this on one problem, okay? It's going to be the last one. It's going to be number 10. So let me just give you some points. It's number 10. Yes, said number 10. That is an A. Now, what I'm going to do is I'm going to give you 4 points. And I'm going to ask you to find if 2 of the lines are parallel, perpendicular, or neither. I'll show you what I'm talking about in a second. So write this down. Now, the numbers on the quiz could be a little different. Okay? But the problem, the gist of the problem, the whole idea of the problem is going to be exactly the same. So what I'm going to do is I want you to look at line AB and look at line CD and tell me, okay, what are my choices? Are the two lines parallel? Are they what? Perpendicular. I'll just shorten perpendicular. Or are they neither? And you have to show me why. And I even wrote that on the quiz. I said, show why. All right, that means you just have to show your work. Okay, you're not going to guess. All right, so you're not going to look at this and say, oh, I have no idea. I'm just going to take a 1 in 3 chance, right, and just guess. I'll just put parallel, or I'll just put perpendicular, or I'll just put neither. All right, I'm not going to accept it. Even if you guess correctly, I'm not going to accept it if that's all you do. You have to show what? Why they are parallel, why they're perpendicular. So if they're parallel to each other, what are you doing? You're finding the slopes, and if they're equal to each other, then they're parallel. Then you find the slopes and look at them. If they're negative reciprocals of each other, then they're what? Perpendicular. Okay, if neither one of those things are true, then you write neither. Okay, that's all there is to it. So what do we have to do? What's the work? Find the slopes, that's right. Find the slope of line AB. So here's AB. Let's find the slope. Well, we know how to find the slope, don't we? Subtract the y's, put them on top, subtract the x's, put on the bottom. Of line AB. So what points am I going to use? I got 4 of them up here. A and B, that's right, okay? So you can do it however you want. You can go 4 minus 2 or 2 minus 4. How do you want to do it? 2 minus 4? Okay. So 2 minus 4. I went y2 minus y1. Now what do I put on the bottom? x2 minus x1. So this is my x2, which is 3, minus what? A negative 3. And let's work that out. 2 minus 4 is negative 2. 3 minus negative 3, it's the same as 3 plus. That's 6. Always reduce it. What's that? Negative 1/3. Just by doing that, can I tell if they're parallel, perpendicular, or neither? No, I got to compare them to something, right? What do I got to compare them to? The slope of the other line. That's right. So now let's find CD. All right, find the slope of CD. Do the exact same thing, except we're using 2 different points, C and D. So let's subtract the y's. Let's do it in the same order that we did the other one. So it's negative 3 minus negative 4. Good. Those are my y's right there. Now let's do the x's. So I've got negative 2 minus 1. Let's see what happens here. Plus a negative, or sorry, minus a negative is plus. What's negative 3 plus 4? It's 1. Okay, what's negative 2 minus 3? Add the opposite. That's negative 3. Now, let's look at them. I got negative 1/3. I got negative 1/3. So what's true about these 2 lines? They are parallel. And that's your answer, technically, but this is your why. Okay, this is why they're parallel. I need to see it. I need to see that both slopes are negative 1/3. Right? If all you do is just write parallel for your answer, even though that's correct, you're not going to get it right. Everybody got that? All right. So that's number 10 on the quiz. It's only one problem, so it's not that big of a deal if you get it wrong, but it's good to know. All right, we're gonna actually use this information later on. All right, this is not the only time we're gonna use it. We're gonna use it to do stuff later on. All right, let's go through. I got time to do the rest of it. So here's the other stuff that's going to be on the quiz. So all that just to give you number 10, how to do number 10. All right, let's go through the other ones. So numbers 1, 2, and 3. I ask you on 1, 2, and 3, and I don't normally do this. This is a little bit different, but I ask you to write the formulas. I've asked you to memorize some of these formulas, and so you're going to have to write them down to be able to get the question right. So what do you think the number 1 is? Write the formula for the what? Distance. That's right. So let's do it right now since we're reviewing. You remember how to do the distance formula? Big old square root. And what's inside the square root? Put parentheses squared plus another parentheses squared. What goes inside the parentheses? x1 minus x2, and then y1 minus y2. So that's number 1. You don't even have to do any math. All you got to do is just write down the formula. Pretty easy, right? I mean, I'm hand delivering it to you. It's like I'm giving you the answer key, at least for the first three anyway. All right, number 2. What do you think the other formula is? What's the next one we did after distance? Midpoint, good. All right, so let's do the midpoint. Remember, it's an ordered pair, so I write it as an ordered pair. So you put parentheses and a comma in the between. All right? And then I always start off doing this. Maybe you do, maybe you don't, but I always do that. And now we got to figure out what's on top. What do I do to the x's on top here? I add them, okay? That's the difference between midpoint and distance and slope. Distance and slope, you're subtracting the x's and the y's. On the midpoint, what are you doing to the y's? You are adding them together. So make sure you keep that straight. Okay, add for the midpoint. And then we add the y's. So there's your formula for the midpoint. Everybody good? Yeah, it's easy, right? Just memorize it. I mean, you're going to have to know how to use it on the next several problems, but you got to know the formula to do anything. All right, what's the next thing? We just talked about it today. The slope, right? So I'm going to put m for slope. Okay, put a little fraction thing right here. What do you put on the top? Yep, you got it. y2 minus y1, and on the bottom, x2 minus x1. Yep. There you go. So there's your first 3 questions. Those are exactly the questions, exactly the answers, all right? But I do that to make sure that you memorize these formulas because you have to know those formulas. Now, in order to do numbers 4 through 9, you have to know those formulas. If you don't know these formulas, you can't do 4 through 9. It'd be impossible unless you just got wildly lucky and guessed it. But even then, I would mark it wrong if you just guessed and stuck an answer down because I got to see how you got your answer. Everybody got that? All right, let's do a couple. We got some time. We made better time than I did in the other class. We were kind of pushing it a little bit. So let's do a couple examples here. So numbers 4 and 5 on the quiz are going to be finding the distance. Okay? And so they're going to give you 2 ordered pairs. So they're going to give you 1 ordered pair. I think I put an and in between. Yep, I put and in between. Then I give you another ordered pair. I don't know, let's just make up something, okay? I don't know, -2 and what? Give me a nice easy number. Nobody? Okay, 1. We'll use 5 on this one. 5 and, let's stick another negative in there just for fun. Negative what? 3? All right, good. So we're trying to find the distance between -2 and 1, or -2, 1, and 5, -3. So how do we do that? Well, we use the distance formula. We already wrote it down earlier. So I'm just going to throw the numbers in right now. All right, so I subtract the x's. So what are my, again, it doesn't matter what order you subtract them in. You could go -2 minus 5 or 5 minus -2. If you go 5 minus -2, then you don't have to worry about having a negative in there. And then let's do the y's. I got 1 and -3, so I'm going to go 1 minus -3. Everybody okay with that? That's my x, that's my y, that's my x, and that's my y. So that's why I put those points in the way. Can somebody get the door for me? All right, so let's do this. Let's do some math. And you don't even need a calculator for this, do you? 5 minus -2. What happens here? Plus and plus. 5 plus 2 is 7. What are we going to do that 7, though? We're going to square it. We'll do it in the next step, okay? You might be able to do that in your head and put it right there. That's fine. What about this one? 1 minus -3. That's going to be 1 plus 3, which is 4. And we're going to square that. We're almost done. 7 squared, 49. Plus 4 squared, 16. Again, you should be able to do those in your head. I'm not going to give you any crazy numbers. I'm not going to give you any decimals or fractions or anything like that, okay? They'll all be decently small numbers, nothing crazy. They're all 1-digit numbers. I'm looking at it. Yep, everything is just a 1-digit number, and it just makes it a lot easier. Now, this one, what's that, 65, is that right? If I do the math right on that, yep. All right, you don't even have to do anything with that 65. You just circle it. You got to keep it under a square root. Don't just write 65. Okay, it's got to be the square root of 65. There's no reason to put that into a calculator, even if you have a calculator on you. I'm letting you use a calculator, but there's no reason to change that to a decimal. Just leave it like that. Circle it, you're good to go.
So you could do like, for when you're adding the x and the y, you can switch them?
Yeah, it doesn't make any difference. Because watch, if I did it the other way, I got -2 minus 5. That would have been a -7, but it would have been a -7 in parentheses squared. And when you square a negative, it still comes out to positive. So the only thing that switching the x and y does, it just changes the sign of it. Okay?
You could put the y like different than when you do the x. So you could do like x1 first, and then you could do y2 first. Or no?
Well, like this is x1 minus x2. So you have to do those together. You can't go x1 minus y1. You can't do that. But you subtract the x's. I could have subtracted the y's first if I wanted to, because is 16 plus 49 any different than 49 plus 16? No. So if I wanted to, I could have done the y's first. I don't know why you would want to. I always do the x's first just because x comes first.
Can you do x1 minus x2?
Yeah. Yeah, that's what I did right here. That's what I did right here. Okay, I just switched the order. Yeah, it doesn't matter. The only thing that does, like I said earlier, the only thing that does is it changes the sign. That's all it does. It still keeps it a 7, right? Except one's positive and one's negative. But when you square a negative, it's always going to be positive anyway. So it really doesn't matter what order you do it in. Okay? I just did it in the order so I wouldn't come out to a negative, just because it just looks a little nicer. That's all. That's the only reason I did it like that. And the same thing with this. It just looks a little nicer seeing 7 squared instead of -7 squared. Everybody good? And this will not be -49 because you're squaring the negative, right? So it's not -49. It's positive because you're squaring the negative. It's -7 times -7. And just keep your answer like that. It's perfectly fine. It's exactly the way I want you to write your answer if you had something like that. We good with that? All right. So that's 4 and 5. Yep, let's do midpoint now. So that's what? 6 and 7, right? So number 6 and 7 on the quiz is find the midpoint. All right, and again, we give you 2 ordered pairs. They kind of all look the same, right? These problems, numbers 4 through 9, they kind of look the same, but they ask for 3 completely different things, all right? 3 completely different formulas, but it starts off looking the same. I don't know, let's just make something up. Give me a good point here, nothing crazy. 3, 5, you said? Okay, what's one over here? You said 2, let's use 2, what? 7? Let's go 7. Okay? Everybody with me? All right, so how do I find the midpoint? It's an ordered pair, right? So I write my parentheses and my little comma. It's midpoint, so I divide by 2. Now, what do I do? What do I do to the x's? I add them up. Which ones are my x's? 3 and 2. So I add those up. 3 plus 2. What do I do over here? Add the y's. What are my y's? 5 plus 7. All right? Now, we just finish it up. It's pretty easy. 3 plus 2 is 5 over 2. And then this is 5 plus 7 is 12 over 2. I always have to simplify my fractions, though. That first fraction is already simplified, isn't it? 5 over 2, just keep it 5 over 2. There's no reason to change that to a mixed number. Now, it is 2.5. If you wrote 2.5, that would be okay, but you don't need to, right? Don't even take the chance of messing that up. Just keep it 5 over 2. But this one you do need to simplify. What's 12 over 2? It's just 6 over 1 or 6, okay? And that is how I'd write the answer. Remember, it's a midpoint, so your answer should look like a point. Now, I don't want this to happen, but it happens almost every single year I teach this, is that somebody's going to do the midpoint and they're going to come out to like the square root of 13. Does that make any sense at all for midpoint to be just a single number? Or some people will say the midpoint is 7 and that's it. They'll circle 7 for midpoint. Does that make any sense whatsoever? No, because it's not a point. Everybody see that? Now, if you put 7, 0 or 0, 7, that would make sense. But don't just write a number answer. It has to be a midpoint. It's got to be a point. One more, and then we'll be finished. We're looking good on time. We already talked about this, but what do you think numbers 8 and 9 are? Slope. That's right. So they give you 2 problems where you have to find the slope. So this shouldn't be a problem at all because we talked a lot at the beginning of class about this. Again, let's just come up with our own points. All right, give me a good point here. Give me one negative at least, or both of them. Negative 5, 8, okay? Give me negative 7, negative 4. Okay, good. All right, so let's find the slope between those 2 points, okay? So I write slope equals, M is for slope. Put a little fraction thing. So what do we do on top? We subtract something. What do we subtract? The y's, right, subtract the y's. Again, it does not matter what order you subtract them in, as long as what? You subtract the x's in the same order, okay, in the same order. So how do you want to subtract the y's? You want to go y2 minus y1 or y1 minus y2? 2 minus 1? Is that what you said? Okay. Yeah, we're used to doing it that way, so let's just do it like that. So let's take the second one, negative 4, minus the first y, which is what? 8. Let's do the same thing with the x's and put them on the bottom. So you have to go in this order. If you did this order on the y's, you got to go in the same order for the x's. Everybody got that? So it's going to be what? Negative 7 minus what? Negative 5. And let's just work that thing out. Negative 4 minus 8. Add the opposite. It's negative 12. Good. Ariel's on fire today. He's ready for this. Okay, and then this is plus plus. Negative 7 plus 5 is negative 2. Always simplify your fraction. Negative over negative is positive. 12 over 2 is 6. Some people like to write a slope with a rise and a run. Okay, either way, it's perfectly fine. I don't care. You can just write 6 and circle it, or you could write 6 over 1 and circle it. I really have no preference. Make sense? All right, so you got 2 of those to do. All right. And then you got that one that we talked about, parallel, perpendicular, or neither. All right, that's number 10. Everybody good? Feel prepared? Feel ready? All right. Don't just use this time and say, yeah, I feel pretty good about this. All right. What should you do at home? You should go home and practice. All right. I'd let you hang on to that slope worksheet just so you could go through it and have some to practice. I've given you everything back. Okay. All your homework has been given back to you. Go through some of those, practice them. People ask me all the time, how do you study for a math test? You do problems. That's how you study for a math test. You do problems. Okay? That's what you should do. So make sure you do it. Watch a video or two. Watch this again if you need to. Scrub through the stuff where I'm just yapping on and on. All right? But get to the stuff that is important to you and be ready for it tomorrow, okay? And tell all your friends, okay? The ones that aren't here today, tell them. I mean, because if it's a test and you miss a day before, I'll give you an extra day, not on a quiz, all right? If you miss a review day for a quiz, that's your problem, all right? You got to be here, all right? So it's on YouTube anyway, so they shouldn't miss it.